We are going into Module 5, Lesson 14 today. The objective is solve real-world problems involving the area of figures with fractional side lengths using visual models and/or equations. Problem 1 says, George decided to paint a wall with 2 windows. Both windows are 3.5 feet by 4.5 feet rectangles. Find the area the paint needs to cover. This is a real-world problem because you probably all have walls and they probably have windows with them. And if you want to buy paint, you need to know the amount of paint to buy. So the first thing we're going to do is find the total area of the wall. So I am going to label on the side, wall. And we have 12 7/8 feet times 8 feet. 12 7/8 times 8. And up here, I'm going to write our formula. Remember, area equals length times width. That's super important to remember throughout this lesson. And we are going to go ahead and use the distributive property. And we have 12 times 8. Plus, we're going to distribute the 7/8 times 8. So, Mrs. Walking, what is 12 times 8?
12 times 8 is 96.
96. And then we have 7/8 times 8. So what's 7 times 8?
56 eighths.
56 eighths. And underneath there, I'm going to go ahead and rewrite 96 plus, well, I know that 56 over 8 is equal to 7. So, what's 96 plus 7, Mrs. Walking?
103.
So, the total area of the wall is 103, and I'm forgetting something very important, and that is my label, feet squared. Now, we need to figure out the area of each window. Remember, there are 2. That's going to be important at the end of solving this problem. I'm going to go ahead and change my color. And the windows are 13.5 feet by 4.5 feet. So again, I'm going to label windows. And that's 4.5 feet times 3.5 feet. We need to use the distributive property again to solve, and I'm starting with the 4. 4 times my whole number of 3. Plus, I need to multiply 4 times 1/2. So that is the 4 times 3, 4 times 1/2. Plus, now we need to work on this 1/2. 1/2, we're distributing it to the 3, 1/2 times 3, plus 1/2 times 1/2. 4 times 3 is equal to what, Miss Purdy?
12
plus 4 times 1/2
would equal 4 halves, which would equal 2.
2 wholes, she said.
And 1/2 times 3 is 3 halves, or 1 1/2. And 1/2 times 1/2 is 1/4.
1/4. So now I have 12 plus 2 plus 1.5 plus 1/4. I like to start by adding all my whole numbers. Mrs. Walking, what's 12 plus 2?
12 plus 2 is 14.
And one more?
That would be 13. No, 15.
15 and 1/2 plus 1/4. But I cannot add those because they do not have a common denominator. Whatever I do to the top, I have to do to the bottom. And I know that 2 times 2 is equal to 4. So I'm going to multiply the 2 on bottom times 2 and the 2 on top times 2. So now I have 15 and 2 halves.
2/4.
I'm sorry, 2/4, thank you. Plus 1/4. And what's our final answer?
Be 15 3/4.
And we are forgetting an important part, and that would be
Our label.
our label, feet squared. So I'm going to go over here and look at this picture because now I know that this window is 15 3/4 feet squared, and this window is 15 3/4 feet squared. Now, there are 2 windows, which means I'm going to have to put those windows together. So I have 15 and 3/4 plus 15 and 3/4. I know that 15 plus 15 is 30, and now I have 3/4 plus 3/4, and that's equal to 30 and 6/4, or how else can I write that, Miss Purdy?
Well, 6/4 is the same as 1 and 2/4, so we could add that 1 to the 30, which equals 31, and 2/4.
Okay, so now I know what the total area of the wall is, and I also know what the total area of the 2 windows is. And I can label that here, both windows. However, I don't know what the area is of the wall that needs to be painted. So in order to solve that, I'm going to have to subtract. I'm running out of space. We're going to do it right here. So the area painted, and that is 103 minus 31 and 2/4. Mrs. Walking, can you help me solve 103 minus 31?
3 minus 1 is 2. And 10 minus 3 is 7.
So now I have 72, and I still have
Your 2/4.
2/4 left to subtract. Miss Purdy, can you help me solve 72 minus 2/4?
Well, if I take 1 whole away from the 72, that would be 71. Then I could take 1 whole minus 2/4, which is still going to be 2/4. So your answer is 71 and 2/4.
So our total area that the paint needs to cover, and I'm going to zoom in up here where I have room. The area that needs painted is 71 and 2/4 feet squared. That is problem 1. Quite a bit of work there. Let's go ahead and look at problem 2. Miss Purdy, can you read that problem for me?
Joe uses square tiles, some of which he cuts in half to make the figure pictured on the right. If each square tile has a length of 2 1/2 inches, what is the total area of the figure?
So the way I'm understanding this problem is that we are going to have to solve it in 2 different parts. The first thing we're going to need to know is the area, I'm going to zoom in, of each tile. And the second thing we're going to need to know is right here in our question. What is the total area of the figure? So we also need to solve for area of the figure. And there I'm labeling my work so I can keep it straight. So the first thing I know is that each tile is a square, and squares have the same length and width. And if one side length is 2 1/2 inches, that means the other side is 2 1/2 inches. So again, we are using the distributive property to solve, and we're going to start with our 2 here. 2 times 1/2 plus 2 times 2 plus, now I am done with the 2 here. I distributed both parts of the second number. Now I need to distribute the 1/2 to both parts of the second number. 1/2 times 2 plus 1/2 times 1/2. Mrs. Walking, can you help me solve 2 times 1/2?
I can. 2 times 1/2 is 2 over 2, which is the same as 1.
2 halves or 1 whole. 2 times 2 is?
4.
1/2 times 2 is?
That's the same as the first problem, just reverse, so it's still 1.
Because 1/2 times 2 is 2 halves or 1. And the last one is?
1/4.
1/4. So those worked out nicely. We have 1 plus 4 plus 1, which gives us?
6.
6. And we have 1/4 left, so it's 6 1/4 inches squared. So the area of each tile is 6 1/4 inches squared. Now I need to solve for the area of the entire figure, but the first thing I need to do is look at the figure. I don't know how many tiles are in this figure, so we're going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 whole tiles. But we also have some halves. And I know that 1/2 and 1/2 is 1 tile, so now I have 11. 1/2 and 1/2 is a whole tile, so that's 12. And 1/2 and 1/2 is another whole tile. That makes 13 tiles. 13 tiles in all. So back over here, the area of the figure, I know that I have 13 tiles, and each tile has an area of 6 1/4 inches squared. So now we solve. Miss Purdy, can you help me do this math?
Yes. First we have 13 times 6 plus 13 times 1/4. So 13 times 6, that is actually 78. And 13 times 1/4 is 13 over 4. So then, how do you want to do it?
We have 78 and 13/4. Ooh, that's kind of an ugly number. How else could we write that?
Well, 13/4, that's 13 divided by 4, so that would be 3 1/4.
So then we have 78 plus 3 1/4, or
81 1/4.
81 1/4 inches squared. So the question back up here where it's highlighted says, what is the total area of the figure? The total area of the figure is 81 1/4 inches squared. Don't forget to do your exit ticket.